Today you're going to start Trig Unit 3, and we're going to be learning about the unit circle. And one of the things we have to learn before we can get into the unit circle is how to convert angles. And so when you had geometry, you learned about angles with degrees. You learned something was 90 degrees, or if it was acute, it was less than 90 degrees. If it was obtuse, it was greater than 90 degrees. And if it was a straight angle, it was 180 degrees. We're going to be thinking about angles a little differently. We'll think of them more as a rotation around, where you can have an angle that starts here and can rotate all the way around. Angles can also go in the negative direction, and we'll get into that more starting tomorrow or in our next class. Today we're just going to learn about converting. So you're used to thinking about angles in degrees. We can also think about measuring angles in something called radians. It's just a unit of measurement. It's kind of like the difference between measuring things in feet or inches and centimeters. We can we could measure a pencil in inches, and we can also measure it in centimeters. It's just different units. And so we need to know how to convert between the two. So we give you a standard conversion and say 180 degrees is equal to pi radians. And so we'll be using pi quite a bit now that we're into trig, and that's because usually when we're dealing with circles, we are dealing with pi, and here we're going to be dealing with a half of a circle. So 180 degrees is equal to pi radians. So to convert from degrees to radians, we're going to multiply the angle by pi over 180. And that's when you're going degrees to radians. To convert from radians to degrees, we multiply by 180 over pi. And it's that simple. So we'll do two different examples. Here, the first example, we're going from degrees, and we're multiplying, we're going to convert to radians. So we want to go from degrees to radians, so that's degree to radians. So we need to multiply by pi over 180. And you want to leave pi in your answer. So what does this look like? I'm going to take 30 degrees. I'm going to multiply it times pi over 180. That gives me 30 pi over 180. You need to simplify or reduce this fraction. You always reduce it down. I like to cancel the zeros off, so then I have 3 pi over 18, which reduces down to pi over 6. So this is considered, 30 degrees is the same thing as pi over 6 radians. On B, we're going to convert 45 degrees into radians. So I'm going to start by multiplying. You kind of think of this as over 1. 45 degrees times pi over 180. That's going to give me 45 pi over 180. We need to reduce this. If I reduce 45 and 180, that's going to give me, 45 goes into 184 times, so it's going to give me pi over 4 radians. Couple more. Here you notice that we can have angles greater than 180 degrees, so that's new for you. Like I said, we're thinking of these as rotations, so we're going to multiply this. We're going from degrees to radians, so I'm going to multiply it by pi over 180. Leave that pi in my answer. So I get 320 pi divided by 180. I think of dividing top and bottom by 10. That gets rid of the 0, so I end up with 32 pi over 18. I can reduce that further, dividing top and bottom by 2. That's going to give me 16 pi over 9 radians. for my final answer. So you notice I always keep pi in my answer. And one more of the conversions from degrees to radians. And here you'll notice that there's a negative. So we can also think of angles opening in the negative direction. So sometimes we see negative angles. So I'm going to multiply this by pi over 180. That's going to give me negative 250 pi over 180. I can simplify this, divide up and bottom, top and bottom by 10. That's going to leave me with negative 25 over 18. Negative 25 pi over 18 radians. So those are all of my conversions from degree to radians.